Assalamualaikum warahmatullah. Guys, okay, I'll do some recorded version of explanation for our OEL2, which I have briefed before in the class, but I think I should record and publish again, such that you can refer for those who have not, maybe you missed the point inside the class. Okay, on this OEL2, we are performing a DC to DC converter design and simulation. Okay, so we have learned on the three kind of converters so far. So we have went through on the buck boost and buck boost. Okay, this table is taken from the last page of our notes of buck boost. The last page of it contain these parameters. So for this formula, it should be V out equal to negative Vs times D divided by 1 minus D. So you have to redefine or rectify this formula. So it should be negative Vs times D divided by 1 minus D. So this one is correct for the time being. All the other formula is correct. Okay, just this one. V out is equal to negative Vs times D divided by 1 minus D. Okay, means that when we have the scenario given inside the OEL statement, said that you have to design a converter such that being used inside the car itself. Okay, the charging system that being used inside the car or whatsoever, you might assume your EV, electric vehicle, as a car, truck, TRUCK, sorry, a car, a truck, a motorbike, and motorcycle, whatsoever. So it's up to your own group. And when charged, it might be charged at home. So you bring home your car, you put outside the house, and you charge into your house punya out socket outlet, and you charge to your car. So we have here AC incoming. Then we have here the DC requirement of your car battery. So in car we have battery. So this battery needs a DC voltage. But what kind of DC voltage? Is it 12 volt? Is it 24 volt? Is it 60 volt? So it depends on the technology that you assume, or from your literature review, how much the voltage that required by this vehicle. Okay, so the incoming voltage is how much? And how much? Is it 220 volt? So you have to assume by using what you have studied, and what you have studied or where you refer. Are you assuming that you are designing in a Malaysian environment or what? So means that for the incoming voltage, it might vary from, if let's say you are assuming that this is Malaysian for Malaysian environment design, so might be the incoming voltage is around 220 volt to 250 volt. So when rectify, how much the DC voltage maximum it will be? So how much the DC minimum, DC maximum? That's one we should use as the incoming DC voltage to your charger system of your car. So means that when incoming is AC, so you deliver to your converter, so there might be a multiple conversion. So from AC to DC, then your system you will design from DC to DC to supply or to charge your battery. Okay, So from this point of view, you might assume that this is a generic. You don't have to design so critical or details about it. Incoming is how much? Expectation of DC is how much here, this point. But your design should be focused on this one. So you assume that the range of incoming here, once it's rectified from AC to DC here, so it might be that you are having you are getting 350 volt, let's say, up to 400 volt of rectified DC at this point. So this is your various input voltage level. Then this is your load, what you required. So it might be that you have a 24 volt battery. So it means that the values of incoming voltage need to be rectified and maintained at 24 volt. Okay, this is your voltage that you have set. So this setting is based on your review. Means that when you perform a literature review, you found that the battery needs this kind of voltage, so you set this as your design voltage. If you assume, or from your review, that you found that Malaysia have this kind of AC voltage, which once you rectify, you will have this kind of voltage range. So this is your input. So this is how you want to set your parameters. Means that once we want to design the converter, we have to know what is our required output, what is our available input. Okay, next is your current. How much the current that you need to deliver to your system. So what is minimum current, what is maximum current? Means that once you take your car home or your vehicles home, sometimes the battery already full, so means that it draws only little current. So what's the minimum current you expect? Sometimes when you bring home your car, the battery almost empty. Means that you need I max. So what is your I min and I max? That's one. So you have to decide. So there you have set your required voltage, output voltage. You have set your variance of your input voltage level. So you have set your minimum and maximum current. Then you find your required L value, inductor value. Okay, what is your inductor value that is required to be placed inside your system? So this is the two approach that you have to set, because once you calculate, the values is not to be placed inside the design directly. You have to increase by 25%. That approach one. Or when you calculate, you obtain your average inductor current, and from that average inductor current, you just increase another. You have used the 40%, and 40% of the delta IL here, the changes of minimum to maximum IL. So use that one as the parameters to determine what is the exactly practical L that you should place inside the design. Okay, means that you have to apply both, because you have to compare, and you have to compare where they you have to compare between these two theoretical, but you have to end up with only one setting. Is it the first or the second approach is the best for your design? Means that you have to discuss theoretically or simulation by using these two approaches, but at last you have to select which one as your final design approach. So use all the outline parameter chapter as your division. Introduction, you have to have intro, background of study, methodology, summation result, conclusion, reference. So at least 5 reference, and the format should be double column. Okay, so the assessment and marking criteria, just like the previous OEL1 that we have submitted before. Okay, for this week, so I'm not around, but you can attend lab to perform this experiment, OEL, within your lab group. Okay, you might consult Puan Shakila if she's available over there, or Encik Fuad. Sorry for the inconvenience because I'm still in quarantine at home, so I cannot attend. You just perform your OEL this week, and please, anything you can text me directly. I will reply through WhatsApp or through online. Okay, that's for OEL. And for OEL is that you have to consider all the available converters here. You can see we have learned about buck, but buck is to step down. We have learned about boost is to step up. We have learned about buck boost. So buck boost, you can step down and step up actually. So which one is preferable for your design? Means that if you have high input but you need only low output, so you prefer just use buck. But if you, let's say your battery, you need to charge at 200 volt, but the incoming voltage might be around 300 to 50 volts, so it means that you have to apply buck boost. Okay, so in preliminary design comparison, you have to compare all the three converters available here to decide which kind of converters that suitable for your design, and then only you use the related formula to decide what is your setting of your duty cycle. Okay, one more is your duty cycle. So means that once your input change, you have to maintain your output be out. So it depends on duty cycle. Let's say for buck, totally depends on duty cycle, and duty cycle versus the available source voltage at that time. Let's say your source voltage go to minimum, so you have to adjust duty cycle accordingly. Okay, you have to prove that using your graph. Okay, I have produced one graph. Let's say we are performing for buck boost design. Let's say, okay, you put the formula inside the graph to compare what happened when you change your duty cycle. If you can see here, okay, we have duty cycle between 0.1 to 1. Okay, from 0 to 1. So increase accordingly, 10%, 10%. We have a fixed input voltage. This is for buck boost. So what is output voltage that we obtain when we change the duty cycle? So we can see that once we increase duty cycle, it will increase. And for buck boost, actually below 0.5, it will become a buck. It will reduce your input voltage. It will step down. Okay, you have input of 10 volt, but you have output of, let's say, 1 volt here. V in 10, V out 1. But once you increase above 0.5, it will become boost. Okay, 0.5 is the unity. You have 10 volt input, 10 volt output. But when you increase your duty cycle, you see, it will increase. Input 10, output 15, 23, 40, 90. But if you reduce, so it becomes 10, output 6. You put in 10, but you produce 4. 10, but produce 2. So below 5 will buck. Above 5 will boost. But there's some instability issue. Once it increase above 0.8, so it will jump too high. So this uncontrolled region should be avoided. Okay, so you can use the Excel to prove the trend of your system. Okay, put inside your graph, inside your report as well. Okay, anything you can just text me. So hopefully you can use this time week, hours to perform your OEL. Good luck for you all. Sorry for the inconvenience cost. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.